Okay, good afternoon, and welcome to the 12th session of the Fall 2017 Sunoikisis Digital Cultural Heritage module. This session will be on the subject of 3D printing, and I'm joined by both Philip Carter and Jonathan Blaney at the Institute for Historical Research at the University of London, and by Tyler Joe Smith and a couple of others from the University of Virginia, who will all speak at different points in this session. I'll start by giving a very quick introduction to the subject and to what this session is going to involve, and then I'll hand over to the others for most of the rest of the session. So in the context of the rest of this digital cultural heritage module, this session on 3D printing comes after sessions that we had, as you know, 2 weeks ago on 3D scanning, where we talked about various technologies, but in particular, we tried out an exercise on scanning using photogrammetry to create 3D models of small objects or large objects indeed, that we had in front of us. Then last week we talked about 3D modeling from the CAD, the computer-aided design perspective, and we used SketchUp Make to, for an exercise, create a model of an ancient building, in this case the Ecclesiasterion of the Temple of Isis in Pompeii, which was then able to be imported into Sketchfab and navigated in various ways. This week we're going to talk about 3D printing, which has an obvious connection to those two sessions, in that if you can create a 3D model, either by scanning an object or by creating a model from scratch, from an imaginary or a reconstructed objects, you can create a 3D file which could then be printed. We could turn that from a physical object or an imaginary object into a digital object and back into a physical object through printing. In 2 sessions' time, but chronologically in about a month's time, in early January, we're going to have the next session in 3D series, which will be on virtual reality and 3D environments, which is taking 3D either objects or buildings or environments of the kind that we've been talking about again in the previous 2 sessions, and taking them in a different direction, and taking them not back into a more physical direction, but into an even more virtual direction, by putting them into an environment that can be navigated, that we can wander around inside that environment, in particular that we can wander around with the help of a 3D headset to get an immersive experience of wandering inside an environment. And in that session we'll see what it looks like to wander around inside a virtual environment of ancient Rome and various other kinds of environment. So for this session we're going to focus on this technology of 3D printing. This is a technology that's, although it's been around for a while, it's still quite young as a technology, in that the technology, the hardware is becoming cheaper quite fast, but it basically involves taking a 3D model and printing it via producing layers of some usually melted substance, and building it up layer after layer after layer after layer until you get a 3D object. This is slightly different from printing as we're used to seeing it in 2D printing, whether we're talking about laser printing or old-fashioned dot matrix printing that some people may remember, which first divides up the space into pixels and then prints those that sort of pixelated, rasterized 2D image. 3D print doesn't so much divide up the space into pixels as dividing it up into layers and doing a slightly more, it's still to some degree pixelating or voxelating the space, but the appearance of how it prints, because it prints in lines, it looks a lot more like a vector drawing of a 3D object, because it's printing these layers. And if you have a 3D printed object, which I don't know how clear this will be, like this 3D printed small calyx that I use for examples, possibly using the black one is not going to make it very visible on the camera. I've got another one, luckily, that I made in blue. You may be able to see, if I move this very close to the camera, that this is printed in layers. Each layer is something like a fifth of a millimeter thick, but they are still visible in the texture. And certainly, if you were if you were here and I could hand this to you, you'd be able to feel the texture on the surface of this is printed on these layers. If it's a very, very high resolution print, of course, that becomes very smooth and you don't necessarily see those pixelated layers, but nevertheless, that's how you print. And this, we'll come to later when we talk about the technique of printing. This becomes relevant for how you print an object, because printing this layer on an object, which has nothing beneath it, then becomes fairly complex, and we have to have various solutions for how to print something above empty space, as it were, because it's printing one layer at a time. So that's the basic technology of 3D printing. 3D printing, of course, can be done in many different kinds of materials. As I say, they're usually materials that can be printed or otherwise liquefied. The printing that we do here, we use PLA, which is polylactic acid, which is a biodegradable substance. I mean, it looks and feels a lot like plastic, but it will actually, if you threw this model onto your compost heap, and within a couple of years, it would have degraded harmlessly into the soil. But 3D printing is very often printed on various other kinds of plastic, and also at different scales. You can 3D print using concrete, and people have printed entire buildings in this way. You can 3D print using metals. Obviously, the temperatures have to be much higher to melt them, and you can print in materials such as chocolate or cheese or whatever for slightly more novelty effects. We haven't printed anything in chocolate or cheese here, but it might be fun to try. The final thing I want to say about the context of this is the part of the context of what we're doing here, and this is, I think Philip and Jonathan may talk about a little bit more, is that we're talking and thinking about 3D printing in the context of a 3D lab or a 3D center that the School of Advanced Study has set up. And this is something that is primarily based in the Institute of Clinical Studies and the Institute of Historical Research, where we've purchased a small amount of equipment, including two, by far the most expensive parts of it were two 3D printers, but also a few other things, with a view to experimenting with all of the different kinds of 3D that we've talked about in this module: scanning, modeling, printing, virtual reality. Experimenting with it in order for us to learn how it works and what the potentials are, in order that we then be able to teach these materials, both to students and to the general public, and also in the longer term with a view to setting up collaborations and research projects with a view to raising funding to do funded research in these areas. So while we're at this point, we're part of the part we're working on today is the part where we're teaching. Obviously, we're talking to you all about 3D printing, but we're still very much at the stage where we want to learn how to use this and in what ways this will be useful to people. So we'd be very interested in suggestions from you or suggestions from anyone else for possible collaborations, for possible uses of this technology and ways in which we might work together on this sort of stuff in the longer term. But I'll hand over now to some of my colleagues, my co-presenters. Firstly, Philip and Jonathan are going to talk for a few minutes about some of the research potentials of 3D printing and the work that they're doing in the IHR. And then a little after that, Tyler Jo and her colleagues are going to talk a little bit about the use of 3D printing in teaching. And we'll come in the teaching of ancient art, and we'll come and talk about that. And then a bit later, we'll talk about some slightly more practical approaches and ways in which you might use 3D printing as students as part of your work as well. But I'll start off by handing over to Philip and Jonathan. Hi.
Hello. Hi. My name's Philip Carter, and this is Jonathan Blaney, and we're going to spend the next sort of 15 minutes or so just explaining a little bit about our very early experiments in using 3D printing. As Gabby said, we are novices at this, and that's quite useful in a way because we are experimenting all the way through about what works, what isn't working, why we need this equipment at the Institute of Historical Research. We had to make a case for purchasing the equipment, and a lot of that was based on the pedagogical and research basis of the work that we were going to do using 3D. So we've thought a little bit about that, but obviously the thinking that we're doing is developing as we start to make models of the photogrammetry we talked about last couple of weeks ago, but now turning them into 3D models and thinking a little bit about that. So for my half of the 50-minute session, I was going to say a little bit about the background and some of the perceptions that I have as a historian about the uses of this sort of additive technology. And then Jonathan's going to finish with a case study of something we are printing at the moment. And the different directions that that kind of work is taking us. Sometimes we're quite surprised by the things that we are learning and the things we're made to think about as a consequence of that, which we can then feed back to our students in history departments and so on. So I have a short PowerPoint demonstration with some slides, which hopefully will do better understand what we're going to talk about. And if I just move on to explain the context of the Institute of Historical Research's interest in 3D printing, we bought a couple of months ago a relatively expensive Ultimaker 3 printer. We chose something that was going to be good quality, but not such refined quality that we were not able to share it and use it. So we want it to be used, and we wanted people to experiment using the printer. So we chose it as a sort of middle-of-the-range machine that would allow us to get many things wrong and to encourage other people to come and try. And that will include, given the nature of the Institute's work, that will include members of the public too. So we thought hard about what kind of equipment we needed, and then went forward from there. The examples I'm going to give you in my section are really going to focus on some items of material culture from the 17th century. The Institute at the moment is hosting an exhibition.
You're not screen sharing at the moment. You know that?
Oh.
Okay.
All right.
I wasn't sure if you were meant to be.
And then screen share. Oops. Sorry, this is a bit amateurish. What we just.
That's all right. No, this always happens.
Okay. Is that now visible? You see our slides?
No, we're still seeing you for the moment.
Okay. Oh, yeah, sorry. Now we
okay, yes, you're now screen sharing. Yep.
Better?
Yes, perfect. We see it.
Okay, my apologies for that. I was talking at length about an Ultimaker 3. There's a picture of an Ultimaker 3 that you now see. The reason for the slides partly is to show some of the objects that we are thinking about sharing and printing. We have an exhibition at the Institute at the moment, which is a collection of artifacts raised from a shipwreck from 1665, a ship that sank in the Thames. And we have a range of objects. Some of them are very everyday, like the clay pipes you can see. Some of them are more distinctive in terms of jugs, a Bartman jug, they'll talk about in a moment, spoons in the bottom right-hand corner, and remarkably leather shoes that have been preserved in the riverbed. What we're doing with this exhibition is taking some of the objects and photographing them, creating them as 3D models, and then starting to print them. And this is making us think about how we can use them for teaching at the Institute, but also how we can instruct people in the practice of making and doing their own modeling, which I think is a very important thing for historians. It's very noticeable, and obviously a lot of people watching at the moment are probably coming from a classics background and are probably more familiar with this kind of approach to the subject. I think for historians, and certainly early modern historians onwards, there is very little 3D work going on in British universities, and 3D printing is something that is very alien to historians, which is quite rare and quite odd in a way, given the importance of material culture as one of the dominant themes in historical studies. So linking that interest in material culture and what it can tell us about the experience of the past with replicate images and surrogate images on, through 3D printing is something we're very keen to explore. So in a way, just to summarize, what I think are our, in a way, quite simple observations so far. I think there are clearly things that classicists and archaeologists and historians share in terms of the value they can take from 3D fabrication. These will be very obvious and well known to classicists in particular. The obvious things such as the ability to create something like the drinking vessel that Gabby showed a moment ago, to be able to take it along to a seminar, to create multiple copies of something, to drop it on the floor by accident, and for that to be okay, for many people to handle it, to use it, to try it out, to take it away, without there being consequences. And that's something clearly that applies to historians for certain subjects and certain objects too. I think the second area that we've discovered of being of value is that we can, and again, this is a close link to practice amongst classicists, is the ability to recreate parts of missing objects. And the Bartman jug that you see here from 1665 is a good example of that. We could, from photographs, recreate the top half. You might be able to see on the slide, it's a little figurine with a beard and half of a face. The top half of the man's head is missing, which will be the spout and the drinking handle and so on, or the carrying handle for the jug. And we can recreate that to show an object that has been lost for hundreds of years in its full display. And this is obviously something that a lot of museums do frequently. In a way, those are fairly obvious applications. And from a historical perspective, it seems to me, and from people I've spoken to as we think about our uses of 3D printing, that the more interesting applications are not about recreating objects so much as experiencing those objects in the classroom and thinking about what it was like to use those objects in particular societies. And here, in a way, the analogy with paper printing seems interesting and useful, because you could, for example, scan a 17th century text and then print that and share it with members of your class. And they would have not the book, obviously, and not the marginalia, so there would be limited, it would be of limited value relative to the volume itself. But you could share the experience of the writer, the experience of the reader to a certain extent. And so too, I think, with 3D images, the printing of 3D images, it's the potential to think about the experience and the history of experience based on the objects, which seems to me one of the things that this is doing that other forms of historical creation cannot do. And in the reading that was attached to this particular module, I was very struck by the idea that a number of the commentators come back to, which is that this isn't creating the past, this is creating a way of looking at the past by an engagement with a 3D model. So just to go on to a couple of examples of how we as historians might think about recreating the experience of living in the past through the use of 3D printed objects. Clearly, there are obvious ways in which we can deal with life of the everyday. So the clay pipes that you saw in relation to the museum exhibition that we have here at the Institute, we can print those, we can try them out, we can experiment with particular forms of material culture that was everyday, which was often lost because it was so intangible and so easily disposed of. And another idea that we have is to recreate cutlery so that we can eat and dine in the 17th century style, which is going to be very different from eating the food of the 17th century using modern day cutlery. So recreating the everyday experience of everyday individuals seems to be something that we can add to of life of the past. And the history of experience and experiential history, which is very fashionable alongside the material cultural turn, seems to be something that this plays to very well. A second category could be, again, this is a research area that we're interested in at the Institute, which is digitizing records of furniture history from the 18th century. And to those digital records, which is standard text digitization, we could then add images, 3D images, and from that 3D printed examples of how individual pieces of furniture were put together. We could recreate, we could remake examples of furniture that we simply couldn't be allowed to have our hands on in the current in a museum environment. But if we could recreate the parts of furniture for this particular project, then we can teach students and we can learn ourselves how they were put together and how indeed those designs progressed over decades, how individuals in the past would have learnt from what existed and how they added to it. And Jonathan's going to say more about this in a moment, about in relation to a particular project we're doing here at the Institute at the moment. A third example would be a project that one of our colleagues is interested in using the 3D printing technology for, which is early modern printing blocks, by which 16th and 17th century covers for books were put together and early forms of printing. It's very difficult to get hold of and to be able to use the originals, but if we can print surrogates of these blocks, then we too can recreate the printing experience, and we can see how that was done. We can learn what it was like. In effect, we're moving from a history of the everyday to a history of work and manufacture through the use of 3D objects. And finally, staying with printing blocks, we can go the other way. So we can see the legacy of the printed blocks in terms of the text, and then we can try to recreate as 3D printed objects examples of the blocks that made that text, because many of those blocks will have been lost and cannot be recovered. So it's a way of form of historical recreation, allows us new opportunities to engage with histories of technology in the past. And then finally, from me, just a few questions and thoughts that have arisen to us and to other historians at the Institute in relation to history in particular and the 3D. I would identify these as, what are the particular needs of a historian? Is what I've been saying of value to classicists and archaeologists? Are there things that we can learn? I'm sure there are from classics and archaeology, but is there a distinctive application of 3D printing for history? And looking at the literature, it's very telling. There is very little directed towards historians aside from the very basics in terms of manipulable content and shareable content. And leading on from that, is the use of 3D printing associated simply with a particular period in time? Medieval, it makes perfect sense because artifacts are rare. Early modern, it makes use of an increasingly consumer society where items are often disposable and have been lost. But for the modern period, for the 20th century, is there a value to 3D printing, or is this very much a technology which suits the rarity of artifacts in the early modern period? One of the things that we have learned from reading around the subject is that we shouldn't aim for perfection. We're not looking to recreate the perfect vase or the perfect pipe. We're looking to think about the ways that we can experience that object and to move from object to the history of experience. And I think finally, just the final 2 points from our observations is, it's really not for us necessarily as makers or trainers of 3D printing technology to come up with the ideas of how it should be used. We should be talking more closely as historians to museum collections in terms of what we think as historians they should print or would like to print for the benefit of history teaching, but also then taking it further to historians in particular to ask them what they would think valuable in terms of printing, and to follow on our experiment in 3D printing from there. Thank you.
So just to follow up with a practical example from what Philip said, to emphasize this again, we only just got this printer in August and no one on the team had ever used one before, so we were and still are really novices. But after a successful test print, we decided that we needed a project to test the capabilities of the printer, but also to learn through doing something that had more of a structure than just printing individual pieces that took our fancy. So what we decided to do was to make a 3D clock, which we downloaded from this address on Thingiverse here. So someone else has done all the designs and created the models. All we have to do is print them and put the clock together. So the clock has lots of different parts and types of material, all made of PLA, but doing different functions within the mechanism. There are about 42 pieces that you have to print, which is almost the entire clock, with the exceptions are the weight, which provides the motive power for the clock, is 1.2 kilogram weight. the string or the cord which attaches to the weight, which you can see on the right-hand side of this image here, and also some pins and screws that hold the whole thing together, which again you can see going upwards in this image. So when we started printing, we found most things actually worked quite well out of the box, but a few things went wrong. And the testing of the clock really gave us different levels of precision to test how precisely the printer would print, but also how much we'd mastered what it could do. So those 4 levels are, first of all, does the clock actually fit together at all once we've printed all the bits out? That's the most basic level. If it goes together, does the clockwork mechanism actually turn and do its job at all? Which it could do, but does it keep time? This clock, according to the number of people who have made this on the forum at Thingiverse, does keep pretty accurate time. It loses about a second over 2 hours, which is not bad for a plastic clock. And then finally, on a level of refinement, does it make a ticking noise? And the reason this is of interest to us, I think, is that the ticking noise depends on the density of the plastic print. So people have suggested changing the amount of infill that you get on certain bits of the mechanism to make it denser, and that will then give you a better ticking noise than others. So it does actually mean that we're forced to experiment with the settings of the clock. A couple of things have gone wrong. I'm just going to try and go back onto camera and show you. We've printed the plastic spring. This one was going really nicely, but it prints as a flat disc, and you have to carefully pull it out into the shape of a coil. And I was a bit too enthusiastic about that, and it snapped off at the bottom here. So we've lost part of the spring where it connects to the rest of the clock. And then this one here, I don't know if you can see, but it's not a proper coil. It's sort of lost its helical shape, and although it's all correctly printed, I think we're going to have to try different settings on the print density to try and make it work as a spring. And then something more recognizable as a clock, I hope. You can see the front, these are the hands here, and the individual bits that turn the minute, second, and hour hand. But if I turn it, it's part of the hands are flopping around. And that is because when we printed these individual bits, there's a membrane that gets laid down first, like a bed of thin plastic, which you have to take off after the print's finished. And we were just a bit too keen, I think, to take away bits from the middle of this clock there, this hand here, which means it fits too loosely over this bit here, which is actually going to turn the mechanism, so it's not going to work. This one here, this hour hand, is absolutely fine, I think. So we'll just simply reprint those, and that's the great thing about this. We can get it wrong, and it doesn't really matter. I'm going to go back to screen share. Does that work? Yep. And back to the PowerPoint. But we saw this purely, really, or I did anyway, as learning about the printer and learning about 3D printing. But the interesting thing was that we soon learned that we were actually learning something about the history of clockwork. And I thought back to about 10 years ago, and I visited a fantastic church in rural Oxfordshire in the town of Burford. It's reputedly one of the best churches in the country, St. John the Baptist. And it's got this amazing tower clock, which dates from about 1650. And what I found baffling about this clock was, you can see the mechanism is very transparent. You can see all the wheels. It's very big. It's much taller than a person. But even so, I couldn't understand at all how it worked. And since I've been doing this clock project, I've read up on the history of clockwork, and I've still found that texts which just describe how clocks work are still completely impenetrable to me. But actually putting one together with your hands does give you a completely different perspective. You can imagine if you could make a 3D model of this Burford clock, not exactly imaging the clock as it exists, but a model of the mechanism exactly as used in Burford, then I think printing it, putting it together, I would really understand, and anybody would, how it worked. So this clock was made in about 1650, which actually is a kind of turning point, it turns out, in the history of horology. About this time, the pendulum was invented. It's usually attributed to Huygens. and also the spring balance, which is usually attributed to Hooker. And that changed the accuracy and the size of clocks. And I can imagine very easily printing one Burford clock type mechanism like this one here, and one of the kind of late 17th century, early 18th century clocks, the same size. And I think you could very immediately and intuitively understand the difference in the mechanism. And this is not just a narrow point, I don't think, about the history of clocks, because it's almost a truism of the history of technology that technological advances in one area always bleed into other areas and influence things. So I think it's not just clockwork, which is an issue here. So I've got one more example of the history of technology, which I think you could do quite easily with a 3D printer. And this is the history of the plough. The bit I'm interested in here is labeled number 7 on this Wikipedia article, and that's called the mouldboard. And this was invented about 1200. And according to at least some historians, it changed the history of Europe, because the mouldboard allows the ploughing of much heavier soils than was possible beforehand. And this really changed the center of gravity from southern Europe, with its quite light soils, to northern Europe, which had much heavier and previously quite intractable in terms of agriculture, and up northern Europe to a massive economic expansion, or that is the theory. And I imagine you could quite easily print, it's not a very complex mechanism, the 3 and the 2 are modern, this is a modern plough, so this is kind of changing the level of the plough. I don't think we'd need to print that. But you could quite easily print a plough and then a plough with a mouldboard, and that's, you know, some kind of limited scale, and then try them out with different types of soil, almost in a margarine jar or a margarine tub or something like that, just to test it out. And my final point, before I finish, is that when we first got this 3D printer, I had absolutely no idea at all about what we could do with it. My mind was a complete blank. And Philip made this point very clearly. We don't think it's our job to come up with the ideas. Historians will come to us with the ideas. But just having one in the corner of the office, I think for all of us has changed the way we're thinking about what we can do with it. And it's almost as if having the possibility is creating the ideas, even though we weren't planning to have ideas of our own. So thank you very much.
Thank you, Philip and Jonathan. Shall we hand over to our colleagues in Virginia? You'll need to unmute yourselves. Yes. No, I still can't hear you though. No, we can't hear you. Okay.
Shall I quickly offer an anecdote about 3D printing in the context of a recent exhibition at the Institute for the Study of the Ancient World? We had access to services from the LaGuardia Labs at NYU, where there's a 3D printing operation. And we were participating in a multi-institutional exhibition, and our piece was the supposedly earliest prayer or hymn in written record, the so-called Hurrian hymn, which is preserved on a a tablet that's about this big. And the thing's in the Louvre, and we didn't have it. We were just talking about it, and there was a musical rendition of it that was presented and so on. But we were able to get, from our friends at the Louvre, detailed 3D model. And so the LaGuardia lab worked with us to produce a couple of different 3D prints of the thing. And the one that we really enjoyed was one that used a gypsum substrate, because it gave you the heft of ceramic or stone. And that was pretty attractive. So here's another example for accessibility, for engagement with an ancient object, even if you don't have the actual object available, where 3D printing is valuable.
Thanks, Tom. How are we doing in Virginia? Nope, still can't hear anything. Have you tried, so there's a settings option within within Hangouts, which might give you multiple microphones to choose between. At the top of the screen. And sometimes just changing from default to the only one you've got can, and back again, might fix it. Or alternatively, the other laptop you were using earlier, where you could get audio but not camera, you could use that one for audio, and we use this one for camera.
Hello. Hello.
Okay, we can hear you now.
Just feedback. Can you hear us now?
Yes. Yes, we can hear you fine.
You can hear us?
Yeah, well, I muted us.
We
can. Okay. All right, cool. So we've got audio on one,
yep,
and video on another.
Access.
Great.
So you just need the video there. The video is not working.
Oh, sorry.
The video's on
Okay.
here.
Okay.
Audio's on here.
Okay. Sorry.
It's a good thing we're used to this.
I'm going to talk into this screen, and you're going to hear me on a different screen, I guess. So I'm Tyler Joe Smith from the University of Virginia, and I'd like to introduce my colleagues, Will Rourke, who's sitting here with me, from the University of Virginia Library, and my former student and now research assistant, Blaney Mitchell, who has been a student of mine in Greek vase painting. I'm going to talk to you about our project, which from its inception had a pedagogical. I'll begin by showing you the actual plastic pyxis I'm going to be talking about in a few minutes, and we will be showing you some of our other models of Greek vases as well. So I need to switch now to the PowerPoint. Is that coming up okay?
Yep, that's great.
Fantastic. Okay, so our project was a collaboration of students and staff members at the University of Virginia and faculty members as well. And just to give you a little bit of background to the project and why we decided to do this, as a scholar of ancient Greek vase painting, it's very important to me to enable my students to have hands-on experiences that will enhance their ability to learn about these objects. Being in we're in a large university in Virginia, but we don't have a very large collection of antiquities here. And it's very difficult for students to have access to them in terms of handling them and so on. So I was fortunate enough to have a student a few years ago, Greg Lewis, who unfortunately could not be with us today, but for a good reason, which is that he just got a job. It started on Monday, so he was unable to join us. So let's hear it for Greg. In any case, Greg presented me on the last day of class one semester a small replica of a Panathenaic amphora. You see it there. You see a real Panathenaic amphora on my screen. It's an object of about over 2 feet tall with a capacity of about 10 gallons of liquid. And he made a very, very small replica, a perfect replica of one to give to me as a gift. So I decided to work with Greg to see if this was something that we could do with actual objects. He had actually taken this, this model off of the internet, off of a website, and we decided to give that a try. So we chose we chose objects that are on display in our museum's object study gallery. You see people doing yoga in the object study gallery. That's not an everyday occurrence. But we have, in the object study gallery, we have the classical antiquities, especially the Greek vases, most of which are very small, alongside objects from other cultures around the world. And you see there in the background, next to Greek vases, we have Native American artifacts, pre-Columbian artifacts, Aboriginal artifacts, and many, many other nice pieces to work with. So this is Greg, you see, holding the scanner. So we decided just to experiment with an object to see what would happen if we scanned it, and would we be able to print it. My aim from the beginning of this was to make scale replicas. I did not want to create perfect objects. I want them to have their flaws as much as possible, although they are museum quality pieces, so they don't have as many flaws as, say, excavation pottery would, for sure. So I wanted to make exact replicas of these objects in terms of their size and condition where possible. So we, at this point, I'm going to ask Will to step in and say a few words about the scanning process.
Sure. So this is a handheld laser scanner that we use specifically for smaller objects. It's a Creaform ZX 700. It will scan color, texture, as well as geometry down to about 0.2 millimeters. So that's okay for artifacts. We'd like to do better than that, but that's kind of where we are with the technology. Again, it's a handheld scanner, so the object sits stationary on that plate that you can see on the left-hand image. And there are targets all around it that help the scanner discover where the object exists in real space. Laser beam hits the surface, and everywhere that the laser beam hits the surface, it forms a point in space so that we end up with a point cloud of 3D data, which is then converted to data that can be used as a 3D model, fully textured.
And as you see, it worked.
Yep.
So this is the Pixis. It's obviously not the Canthros that we were scanning in the other photograph. So what I decided to do at that point was to gather up a group of students, archaeology majors in particular, because I felt like this would be very, very useful information for them to be able to learn how to scan, model, and print in 3D as part of their learning about classical archaeology. So we formed our group called 3D 3D Greek Vases. We never actually got the t-shirts made. We're still collecting the funds to do that. So we built a team of undergraduates, museum staff, library staff, graduate students in archaeology, and Greg, our lone member from the engineering school. And we started to go through the process of teaching the students the step-by-step aspects of this, from actually teaching them about Greek vases and how we would draw them and record them in the field or in the museum for archival or research purposes, and to then learning about how to scan them and eventually print them. And that's a photograph of Will there on the right playing a 3D scanned electric guitar in one of the engineering labs. So it was a great teaching opportunity. You can see us there with our original group. I very rarely touch the scanner myself. I really want the students to get the experience and to understand the complications of working with this equipment and technology, and to also get a sense of the sort of before, during, and after of the process. We also visited other places on our campus where similar work was being done. We have something called the Scholars Lab Makerspace here in the university library that enables students to kind of go in on their own and print objects in 3D. These are a couple of other archaeology students, PhD students, who work at Morgantina, one of our excavations, which is in central Sicily, and they are printing artifacts and plans of the site on a very, very small scale using the Scholars Lab Makerspace. We also visited the engineering labs where Greg Lewis, my student who gave me the original little Panathenaic vase, where he was at the time an undergraduate, later a graduate student, because it was really Greg who had the experience going back now 2 or 3 years. He had a lot of experience already with 3D printing because they were doing it in his lab. But they weren't doing Greek vases in this lab. They were, in fact, making replicas of fish in his lab to understand how these fish move dynamically in the water. So there's one of my students playing with a 3D printed fish in one of their big tanks. And we also saw the variety of other types of things that they print. In terms of our own 3D printing, all of our objects are printed using ABS plastic, that's Lego plastic, and mostly they were printed in an enclosed printer, a very, very high-end printer that's in the engineering school. The specs on our printer and our scanner are available on our website, and I'm going to give you the link to that actually in a few moments. As we heard a moment ago, when something is printed, very often there's a level of supporting that is laid down first. And this is a very, very important aspect of printing Greek vases because of their shape and their curvature. And this is a necessity so that the printed model will actually build itself within the printer. We then, of course, had to learn to be very patient. I'm thinking of the gentleman talking about the clock a moment ago. Learn to be very patient about removing the supporting material and doing it carefully enough to do damage to the actual model itself. So here we have the before and after. We have a Corinthian skyphos that's in our collection. The date of that object is probably about 600 BC. And then we have the exact replica of it that we've printed as a 3D model. We've also decided it was important to do quite a lot of outreach for this project. So in the past year or so, we've given a number of presentations at archaeological conferences in particular, such as the AIA and the CAA, the Computer Applications in Archaeology Conference, but also here on our own campus. We've really wanted to share this project and share the information and what we're learning with as wide a spectrum of people as possible. And just, of course, we think about the pedagogical implications. It's very important in my classroom that I'm teaching students about how ancient artifacts were used, how they functioned in ancient Greek culture. We're looking here at artifacts that were made in the archaic and classical periods of Greek history, so about the 6th to the 3rd century BC. And so just playing with things like putting liquid inside them, other objects inside them as well, to see how they feel and how they handle. One thing that we did actually do, and I'm going to ask Delaney to speak about this just for a minute or so, is in my classroom, once we had a good number of models last spring, we got students to volunteer to be blindfolded, and I put them in a chair at the front of the classroom and handed each one of them a model, and they then were able to speak about their model while I asked them questions. So I would ask them questions of an archaeological nature, such as, is this an open or closed vessel? Does it have handles? If so, where are the handles attached to the object? Remember, they're blindfolded while they're doing this. And they all agreed that this was an incredibly beneficial exercise. Delaney, do you want to say anything about this experience?
Yeah, of course. It was very cool because it was tactical learning is not something that you get to experience a lot, especially in your bigger seminar or bigger classes where there's up to 60 people in your class. So it was very interesting to kind of see how what we've learned in class and listening to lectures and transforming it into holding the actual object and being able to say, oh yes, Hydria actually does have 3 handles, and half the images that you see them can only see 2. So it was just really interesting to be able to hold these objects, and even though it's not necessarily the same weight, but like the scale of it and seeing that not everything is perfect has just been essential to the whole learning process and helped us definitely probably do better on our exams than we would have.
Okay, we're just
Stop sharing.
How do you come back up?
Stop sharing.
Stop sharing.
Got it.
Sorry.
This is new for us.
We have too many cooks here. Okay, so I just want to show you very quickly a few of our models. I hope you can see them here on the table in front of you. These are all, as I said, objects that are in our museum. They're exact scale replicas. They have flaws. For example, the Corinthian Scippos I mentioned. I know you can't see this on the screen, but there's a kind of a nick out the bottom of it that comes up in the 3D print. We have cracks even and chips on this other example. Again, another object of the same shape. What's interesting about this also is that we played a little bit with the surfaces of them. So for example, Greg has smoothed this one down and painted it. So it actually feels quite a lot more like an actual lekythos than these more plasticky, lightweight objects do. Another thing that we're doing going forward is we're experimenting with the weights of the objects. I have another lekythos, it's not this one, but where he's printed it without, well, actually this one is as well, come to think of it. He's printed it where it's not hollow. So for example, this hydria is hollow on the inside, okay? But this lekythos is not, it's solid on the inside. And the reason for doing that is, and of course it's the printer that you specify with the printer how to do this, you give the instructions it needs, but it makes the lekythos heavier and it makes it feel a little bit more like an actual artifact. So what we're doing going forward is we're weighing these objects and we're going to try to play with the weights when we print them so that they will be, again, not just showing their flaws and their form, but also they'll have the kind of weight and feel of an actual Greek vessel. I'm just going to turn to Will now and let him show you a couple of websites and web links very quickly.
Sure.
That might be useful for all of you.
We're going to share this, but let me see if those web links are up. You brought them up here?
Yeah.
Okay. So we'll need to go back and share.
I can bring it.
Yep. Okay. All right. We're going to share screen again. Go to the other site.
Okay.
There you go.
Sorry, we're having technological excitement here. Okay, so on the archaeology website of the University of Virginia, we've built a small web page for our project. I encourage anybody who's interested to go to this page, and you'll hear more detail about our project. Our poster, which you can upload here, gives all the specifications of the equipment that we've used and how we went about this. And there's also some nice links here to articles and features about our project that have been in the news.
It doesn't seem like it's sharing the web page.
Okay.
So, here. Yeah. How do we go back to that web page? Are you seeing the web page or are you seeing the PowerPoint?
We were seeing the web page, yeah.
Okay.
You just edited it
Oh.
out. Oh, no, you did. There we go.
Yeah. There you go.
Yeah,
Okay.
we're seeing the web page there.
Cool. Thanks.
There we go. Okay.
So this is what I do at the University of Virginia Library. It's Cultural Heritage Informatics, and so scanning artifacts is part of what we do. We also scan buildings. We like to say we scan everything from artifact to architecture, using other kinds of larger format 3D scanners. But I have created a page here specifically on artifacts, a process we call artifact simile. Where we are procuring data on artifacts of all sorts and all types for all different kinds of pedagogy, including the 3D project. But we're also scanning artifacts with Monticello, University of Mary Washington, and as well as other artifacts with the Fralin Museum, which is here at UVA. We're taking this data a bit further and making it searchable and discoverable through our library system. We're using an open data platform called Dataverse, which comes out of Harvard, where we store all this data from the 3D scans and the 3D processed data in Dataverse. That makes it open to the world, but it also makes it available through Virgo, which is our library search engine. So you can find books and periodicals and articles on the subject, but you can also go and download 3D data directly from our library using this platform. So these, a lot of these Greek vases are available at search.lib.virginia.edu for the world to download and print for themselves.
Your own plastic picture. All right, thank you.
Great, thanks very much. That's that was really useful. So I was going to have a quick conversation now, sort of round table conversation with all of the presenters to talk about some of the issues that arise when you're trying to decide about 3D printing. But what I might do instead is we're running a little bit later than I had hoped because of a couple of technical issues earlier. So what I might do is I might jump straight to a very quick demonstration of the process of preparing a 3D model for printing that will be of use for the students for the exercise. And if I manage to get through that quickly enough, we might come back and have a bit of discussion in the question session at the end, and we'll see how that goes. So all I wanted to show really was two tools which you would want to use when turning a 3D model, whether this is a 3D modeled building, for example, you might have built in CAD, or whether this is a 3D Greek vase or similar that you've scanned. And the first tool I will use when you've exported that model is you might use a tool such as Mesh Mixer, which I think we talked about during the other session. This isn't showing you what I'm seeing on Mesh Mixer, which is actually pretty annoying. You're just seeing the welcome screen. That's not very helpful at all. Okay, let me stop screen sharing that. Let me try and show you check if I can at least show you the other tool that I'm wanting to show. Okay, nope, you're not seeing anything in that tool either. Okay, this Google Hangout is not turning out to be very very cooperative. Let me see what happens if I share my entire screen. That's going to look very weird because my screen is the other orientation than the Hangout. But okay, you can see this very, very small in the middle of the screen. I apologize for that. I'll try and make it as big as possible. I apologize particularly to people watching this on YouTube who aren't able to expand the screen as much as people watching on the Hangout are. So this is a scan of this same Greek vase that I showed earlier, as when I first scanned it and opened it in Mesh Mixer. And I'm just showing this simply to show that the various things that you'll need to do within Mesh Mixer with this, as you'll have seen yourselves when you did photogrammetry, you can rotate, you can tidy up the object. When wanting to print an object, it will be really, really helpful if at least one of the surfaces of the object is fairly flat. And because I wasn't so concerned with the printing of this model with the exact accuracy of the original vase as Tyler Jo was when she showed her models, what I basically did, and also because the photogrammetry I did was much, much less good quality than the laser scan that they just showed. So I had a 3D model which was actually pretty ugly, and it had all sorts of rough edges that were not the rough edges of the original model, that were rough edges of the scanning artifact. And so what I did is I simply did a plane cut and cropped off the very bottom of that model until I was left with a flat surface. And you can see here, this is just after that surface was cut. So the surface is a different color, showing that this is what was cropped off. Okay, and so the I created a plane cut off there so that this would print on a completely flat surface. And I also did a plane cut along the top, which made it almost completely flat. You'll see that there's a section there which is sufficiently rough that I couldn't make it entirely flat. And that's fine, because I was happy for that to stay a bit rough. But so, because I was originally thinking about printing this object the other way up. I was thinking of printing this upside down in the first instance, because, as we were talking about earlier, of the amount of support you need in order to be able to print this would be much smaller if it was printed. If you can imagine, I can't for some reason rotate this the other way, entirely the other way around. But if we were looking at the other way up, the supports between that and the ground, if you imagine this upside down, would be much smaller, and the object here gets smaller towards this area rather than getting larger, so it would print more easily. It turned out that wasn't the best way to print, and so I printed it this way up in the end with the more successful prints. But so having cropped off the bottom was useful. So the two things you'll need to do in this sort of tool is, one, do any large scale cleaning of that kind, cropping areas off if there are other things you want to clean, and so forth. And the other is to make sure that it's a solid object, to make sure that it is airtight, or watertight, as it's called, which basically means, if there are any holes in the object, that's going to be really hard to print. Okay, so there's issues with that make it the printer needs to have a solid object. So once you've done that, and there's an option in Mesh Mixer, which I think is analysis, and if you turn on inspector, it will now, it'll show any problems with this object not being a complete watertight object. As it happens, because I'd already cleaned this one up, you're not seeing any errors with this right now, so I can't show you the process of fixing it. But that's the options you would choose. Anyway, once you've saved, you've created a nice 3D, solid 3D model out of this that's the right shape for you. What I then do is then open this object in the software that we use for our 3D printer, which is, because our 3D printer is a CraftBot, we use this software here, which is called Craftware. Other people working with other printers will use different software. So take this mutatis mutandis, as it were. But for my students, this is the software, and I'll give you the software so you can have a go at this yourselves. This is what happened when I first moved that object from Mesh Mixer, saved it as an object file, and opened it in Craftware, is that it turned up very, very small at the bottom of the screen. That you may not be able to see in the numerical dimensions at the bottom there, that this object is about 18 millimeters across at its largest dimension. So the model hadn't kept, for some reason, its size as part of the original model. The other thing you'll notice about this object is that it is standing on its side for some reason. That won't be the most useful way in which to print this object, and that's not the way up it was when we exported it from Mesh Mixer. The reason for this is that Mesh Mixer and Craftware, they apply different values to the X, Y, and Z coordinates, so they're just in a different order. That part is easy enough to fix. So the first thing I needed to do with this is to change the scale of it, and so I ended up making it roughly 5 times the size it was, and because the dimensions are locked to each other, I only had to change one of them, so that it is now approximately 10 centimeters across. And this gives you an object much closer to its actual size. In fact, I measured it, and that is pretty much its exact size. And the other thing you want to do then is to rotate the object so that it sits on the bed of the printer. And the easiest way to do that is not to fiddle about with rotating and so forth, but to use the drop plane command and simply click on the surface that you want to be flat level with the bed. And it really helps when that's a flat surface. When it's not a flat surface, that causes all sorts of issues. And so there you have the thing sat perfectly level on the bed. I'm going to rotate this just a little bit more so we can see it a little bit more nicely. So it's now sat against the roughly level with the viewer. It's not quite level, but that doesn't matter. I'm not actually going to print it from this. So that's the first step. Then, as I say, when you try and print it from this, it will have problems printing this, right? Because there are several parts of this model over here and over here in particular, where the part that it wants to print doesn't have anything beneath it, and it can't print, it can't layer hot plastic down over empty air and expect it to hold its shape. So for that, we're going to have to ask this software to give this object some supports. So we use the support option. This object, makes this very easy for us. The default setting on this software, I think, is that any surface that is under 70 degrees steepness is considered not to be able to support itself. So we can say anything. See, this surface here, although this is slightly sloping, it's considered it's okay. It can print from here above the layer below it. But this part down here, which is very, very steep, it can't print over here when there's nothing beneath it. So the simplest thing to do is to ask the software to auto-generate support for you. And this is showing you what it would look like if you auto-generated the support. It would print all of the, it would print in either in a different plastic, or in our case, we only have one print head, in just a very much lighter print density, all these supports upon which the overhanging parts of the vase can sit. I mean, this would be fine. I in fact, I found that you don't need to be quite that aggressive with the supports. If you generate support just with an 85-degree steepness, you still get an okay support for your object. You get some parts that are a little bit rough, but that tends to be okay. Note as well that there are supports in the underside, and that slightly hollow part beneath the foot of the vase. And when we printed this the other way up, upside down, it put supports in the middle there of the thing, because that was the underside. And having done that, I'll just show you the last thing we do, which is it does something called slice, which is where it takes the model and it calculates the exact path of the print head through the object. And this really demonstrates for you the layers that I was talking about earlier. These are the layers of plastic printed at 1/5 of a millimeter thickness on the object. It's worth noting, as we were talking about time and cost of this, that the object that we printed, when we printed it at fairly high quality, not the highest quality that this printer can do, but at fairly high quality, this object, which is 10 centimeters across and maybe 4 centimeters high, and I'll stop screen sharing so I can show you the object in front of us again, this one here, took about 4 hours to print on this printer. So it takes a lot longer than printing a few pages on a laser printer or whatever. So and you can imagine scaling this up if you were printing a much larger object. Obviously, higher quality printers presumably would print a lot more quickly. I don't know about the high quality engineering printers you were using in Virginia. Presumably didn't take 48 hours to print one of those larger vases. Presumably it was a lot quicker than that.
Sorry, you can hear me now, right?
Can you hear us?
Yes, we can.
So these objects took between like 4 and 18 hours to print, depending on their size and their complexity. So for example, the Convenors, I guess, well, can you see me? Oh, the Convenors shown here, this one took, I think, the longest to print.
Yeah.
And to scan.
Mm. So even on those big, very high-tech printers, it's still quite slow. Yeah. And the other issue that we found with this was that even with this small object, it takes 4 hours to print. You can't just set it to print and then walk off and come back 4 hours later and it'll be done, because sometimes it'll go wrong halfway through. So I never leave it more than about 20 minutes before going to check on it. Which if it's 4 hours, that's 4 hours having to go and wander have a look, look at the printer every 20 minutes. And if it has gone wrong, there's nothing you can do about it. You just take it away and start again. It just means you've wasted less plastic than you would have done if it were if you left it going for 4 hours, just spraying plastic in all directions, which is what you would otherwise do. Yeah, that's the sort of background I wanted to give to the printing in terms of what students might want to do for an exercise. Did anyone want to make any other suggestions or advice or questions on related to any of that? Or about anything else? One of the things that I wanted to sort of ask when in the sort of discussion that we might all sort of chip into is the sort of decisions that we make about how we're going to print. Right? I mean, there are various decisions to make when you're looking at something like this. There's the question of what size am I going to print this at? This is at more or less true size, but it's a very small object, so that's okay. If it was a much larger object, would I have printed it at full size? And knowing that it was going to take 18 hours, and would I? I probably wouldn't have printed 3 of them anyway. In fact, I printed 3 others than this that turned out less well, so they're no longer here. One of them's at home as a receptacle for olive pips. But the cost, the time cost of printing these things becomes significant. What material are you going to use to print? We as I say, we've been using PLA, this biodegradable material. In fact, I'm not sure this one is PLA. I think this one may be ABS, but which is one of the non-biodegradable plastics, which I don't like as much for that reason. But the PLA that we certainly use for these ones. But there are all sorts of other materials one could choose, and there are cost implications in that. PLA, because it's biodegradable, you couldn't use this to eat or drink out of, or you shouldn't, because it would degrade very quickly if you did this. You couldn't use this to print something that you intended to use as outdoor furniture, because that again would weather much too quickly. ABS would last a lot better in those sort of circumstances because it's a much hardier plastic. This prints at a much higher temperature. ABS prints at a couple of 100 degrees. I think this prints much less, a slightly lower temperature. I think you can print. I forget exactly what it is, but only maybe at 130 degrees or so. So it's much easier to print, and cheaper for that reason. You don't have to heat up as much, you don't use as much electricity, and so forth. So those sorts of questions come up. What quality are you going to print? None of these were printed at the very highest quality. That would have taken even longer. It would have printed thinner layers, and it would have taken longer if it printed it more slowly and at a slightly higher temperature, and so forth. And that would have just multiplied the size, the time taken to print, more than it would have improved the quality as far as we were concerned. I deliberately printed this one in a slightly ridiculous color, so no one could ever mistake it for trying to pass it off as an original Greek vase. But I then, because the object, I don't have the object itself with me, but the object that we scanned is mostly black with some light brown coloring on it, patterning on it. I thought if I printed it in black, I could maybe get some light brown paint and paint the design on this. Obviously, that would have been the other way around. The terracotta of the object itself was in fact light brown, and it was able to be painted and glazed in black, leaving the gaps for the bits that are decorated. But I could have done that bit around. This brown one, although it's too dark a brown for the paint, perhaps if we had smoothed it slightly. This fairly cheap material tends to lose its color if you smooth it. So this might have faded to a lighter brown that we could have then painted over in black, replicating the process of glazing it from the original. So various things that you could have done, but the ridiculous color I actually like the best, because it's never going to be mistaken for anything except what it is. The biggest question that we keep coming to, this is something that Philip and Jonathan and I and Valeria talked about a lot when we were setting up this 3D centre here at the University of London, was given what it is we want to do, is buying a 3D printer actually the right way to go about it? And in fact, when we first started asking people we knew who'd done 3D printing and cultural heritage in various places around, they all said, no, don't buy a 3D printer. That's the last thing you should do. buying a 3D printer is not effective for what you want to do. Outsource to a professional company who do 3D printing, and when you want something printed, send them the files and they'll print it and you pick it up the next day, and whatever else. And that'll be much cheaper in the long term than running your own 3D printer. And I'm sure that was good advice. If what we had wanted to do was to produce one of these every few months, as an output, what we wanted to do was learn how to use a 3D printer, to experiment with these sort of methodologies. We wanted our own machine that we could mess around with, that was down the corridor, that we could, play with, buy different things. We could break when we realized that we were using it wrong, and therefore the several £100 it cost to fix it would really convince us never to break it again. All those sorts of things. I don't know if you wanted to add anything to that.
I think one thing we've found is that as we've got more confident, we've actually started to be much rougher with when we first got it, especially if it's got a glass plate. We were very delicate. We couldn't get the print off the plate because we were afraid to touch it. But we've actually started to become really, not careless, but we've knocked it around the building a few times. We've taken it to a number of events, just carried it downstairs. And I think that's been a healthy thing, actually. We're less scared of it now.
Yeah.
I think the point Philip made about it being kind of mid-range for us has really helped to be a bit more cavalier with it.
It helps that we paid a lot of money to get 3-year full parts warranty on it as well, which, I mean, I guess if you dropped it downstairs, it wouldn't be covered, but smaller issues like the printhead becoming unaligned or something like that becoming damaged would be we can afford to be a little bit more risky with that sort of thing.
Yeah, this is Will at UVA. Being at a library, we see a lot of what's going on in all the departments in the entire university, and a lot of departments are getting 3D printers or some sort of maker technology. So it's important for us to be able to be familiar with that technology, and I would say for each department, it's extremely important for those constituents to be familiar with the technology as well. I think the more you know about the technology, the more of a knowledgeable decision you can make if you need to go to a third-party professional. But I think it's important for everybody in every field to be able to understand not just the output, but the data that goes into it. And thinking more in terms of 3D data rather than 3D models, how data creates models.
Yeah, that's a very good point, and I think that's exactly what we were thinking about. Getting your hands dirty, actually using the object. Sending the file to someone is the last thing we want to do, and then just getting an object back. That teaches us nothing. I could buy a replica Greek vase, in a museum gift shop, that would be better than this, but I wouldn't have learned anything by the process of doing that. So I think the learning how the objects work, the seeing the relationship between the data and the object, all that sort of thing, I think is very important. You don't necessarily have to have your own printer per department, but having a printer that in the building somewhere that you can go and use, get hands on with, have someone show you how it works, I think is very valuable.
Yeah, and a lot of libraries are making 3D printing available to the entire university or college that you're at. So you're going to see them more freely available if your own department can't afford it.
Yeah. Here at the University of London, that's the people who have a 3D printer that they're making available to everyone else is us, as it turns out. We've by investing in this and starting to learn how to use it, various other parts of the university are starting to want to play with it as well and coming up with ideas. Yeah. Anybody else want to add any last points or ask any questions of each other?
Coming from the student perspective, last year I took a class where we had to recreate a ancient house. We were either allowed to create it on SketchUp. We had to create it on SketchUp regardless, and you would either do a 3D model of it or you would print it. My group decided to do the virtual reality walk through the house. But a lot of groups decided they wanted to print their house, and it was just a very rewarding experience for these groups to be able to print their house, and obviously a much smaller scale, and be able to hold it in their hands and see how the rooms interacted with each other, and how you can kind of imagine a little bit how to move through the space. So they were able to use the 3D printers in the library. The archaeology department didn't want to have them at the moment, so having one in the library was very useful and kind of helps us engage a little bit more with new technology.
Yeah, I might add to that. Actually, we helped with that virtual reality, and this brings me back to 3D data. That 3D printing, you want to maintain the idea that 3D printing is an output technology, and there are many output technologies, such as virtual reality or augmented reality. There's CAD, as well as 3D printing. We see these as all output technologies that can be applied towards scholarship and pedagogy, and sometimes they do have crossover. Sometimes we try to bring 3D printing into augmented reality or virtual reality, those kinds of things. But it's important to think of that as an important output platform for pedagogy. One of many.
Yeah. Yeah, I think that's something we very much wanted to try to achieve with this 3D center is linking these things to each other and seeing how they supplement and complement each other, which I think we're still learning a lot about this, but as I said at the beginning, we'll learn more when people start to, and as Philip said quite a lot in his presentation, we'll learn more when people come to us with ideas of things they want to do. I mean, when people come to us, that includes us, right? I mean, the fact that I'm speaking, with one hat as one of the people responsible for the 3D center, and I want people to come with ideas that we can play with. But my other hat, I'm a classicist, so I have ideas for things that I may want to do as well. And it sounds a bit schizophrenic when I put it like that, but I'm talking about having ideas to experiment with, and things. And one thing I was gonna show when I said that printing this took about 4 hours is that in contrast, printing this little fella took about 40 or 50 minutes. I don't remember. It's just a little dragon. It's not it's not a lot smaller than this, but I mean it's simpler in many ways to the thing, and it had less supports attached to it. So this took under an hour to print. So that was not too bad. That was one of the things we've been doing, is printing things that are not obviously classical, things that are not obviously of research value, but there's a sense of how the printer works and having fun with the printer. I mean, I actually don't have any either practical or fun reason to have this, except that it's actually kind of fun having it on my desk now.
We have here a couple of objects from the University of Virginia. We have William Faulkner's pipe that we've 3D printed. So if you'd like one of these, just talk to Will.
Well, it'll be available on Virgo.
It'll be on Virgo. Yeah. And then, which is this?
That is, this is a Corinthian capital from Pavilion 3. This is one of the original Jefferson capitals. Some of the capitals on the pavilions are not original Jefferson, but this one is. And this probably took about 30 hours to print. Right. So this is one of the long ones. By the way, the Faulkner pipes have been engineered to function properly as a proper bubble pipe.
Okay. Nice. Not hot. Not that you could burn something in, but.
Nope. We want to do that.
Yeah. Cool. Okay. Well, we've gone over our originally scheduled time, and we can carry on for as long as we like, but we have gone over our scheduled time. So unless anyone has any other last minute comments or questions, we might draw it to a close here. So thanks very much, everybody. This was great and really useful, I think, and fun session. So. And I think very useful for the students as well, not only for mine but for the other students in various places who are following this. So that's great. Thanks very much. What I haven't been doing is keeping an eye on YouTube to see whether anyone's left any questions there, but it doesn't look like anybody has, so that's okay. And so, I'll just end by saying, see some of you next week for the final session of this calendar year, which is on network analysis and visualization, and then again for the first session in January, which is the last session of this academic semester, on virtual reality, on 3D environments and virtual reality, which will be the last of these 3D things. So, so thank you all very much, and see you soon.
Thank you. Bye-bye.
Bye.
Cheers.